What you see on your screen at this time is a reminder that this advisor webcast is intended for informational purposes only. Any features or functionality described for Oracle's products remains at the sole discretion of Oracle. Now, let's get started with our presentation. Paul, if you're ready, I'll turn the webcast over to you and you can begin.
Great. Thanks, Pam. Okay. My name is Paul Tinker. I'm one of the technical support engineers in the Siebel group. You may have come across me before. I may have handled one of your search requests in the past. Basically, I work on system admin issues in the Siebel area and a lot of crash issues as well. Hence, that's my reason for presenting today. Got a couple of guys as well on the line to act as part of the Q&A session. We've got Taylor Schock. Taylor was previously a tech support engineer. He's now part of the Siebel proactive support team. And Andreas Jelkes. Andreas is one of our backline engineers in Europe, and he's very, very knowledgeable in the crash and operating system and database areas. Okay, so what we've got today is I've put together about 50 plus slides basically related to crashes and crashes on Siebel. So what I was going to do, if it's okay with everybody, I'm going to run through the slide deck first, and there's plenty of screenshots and so on, so to keep people's interest. I'll run through those. Then I was going to plan to do a lab sort of based demo on a Windows 2008 server showing a fairly current active crash that we've got being fixed at the moment by engineering. Then we were going to have a Q&A session basically. So it's quite a lot of slides to go through, so apologies in advance if it's too quick, but the reason being that I wanted to try and throw in as much material as possible so that you guys can maybe watch it on a replay, just to if you want to refamiliarise yourself with the content. Okay, so basically here's the agenda, and the first 2 points there, points 1 and 2, was wanting to actually define what we mean by the term crash, because some people use the term crash quite loosely, whereas we want to actually put some scope around what we mean. And then points 3 through to 7 are the real kind of the elements that I want you to be able to take away from this presentation. Basically, these are the things that I'm really, really hoping that will enable you to do your job better, basically, whether that job as a system administrator, as a Siebel developer, or as an application, a Siebel application support professional. Points 3 to 7 are essentially there to help you do your job better and interact with us in support. And I've also pinned down a couple of sort of broad aims as well for the presentation. So basically we want you guys to be able to self-service your own product, Siebel product crash needs, and also be able to interact with us in a more educated and informed way. So we get kind of extremes of contact for crash issues. From one extreme, you can have some customers who are extremely knowledgeable. They've already carefully looked through the diagnostics, and they'll actually be telling us specifically what they think the root cause of the crash is, through to some other customers who possibly don't even recognise or know that they're experiencing crashes. So the idea is that I'm trying to fix this to everybody, but the idea is that it's just a general education session. Okay. Right, so first section, just the one slide. Basically, a crash, just like for any process, it's basically when a process aborts unexpectedly. And obviously this can be any process from Internet Explorer to Windows Explorer to Siebel processes, but that's the official definition. So basically second level process exception. And these can have a very large number of possible causes, from unsupported hardware or software, memory exhaustion of the process, custom scripting, so PAT-C scripting, misconfiguration, so that's the declarative Siebel configuration, any third-party software issues, for example, custom drivers or something like that, and not forgetting, of course, Siebel product defects. I made a note for myself here as well, really unsupported hardware or software. A good tip on that one is always to make sure that you're running on the supported platform, basically, so that the source for that material is the system requirements and the supported platforms guide. Okay, so I stole these points from an internal presentation that we've had for a number of years now, and it's intended only as a very, very high level possible causes for crashes, but broadly put into three categories. So you've got memory access violation, memory corruption, or insufficient resources on the machine, and I've got a slide for each. So definition of access violation is basically when the Siebel program tries to access parts of memory that it shouldn't have done. So, like it says there, invariably as a result of improper pointer use. This is kind of getting into the realms of what our engineering and engineering escalations group are involved with. But under the hood, as it were, this is the reason for access violation. And the example that we're going to look at in the lab later on, I actually found out just a couple of days ago, is a perfect example of this access violation type crash, because it was due to a null-point exception. Okay. And memory corruption, this is historically the most hardest type of crashes to troubleshoot. Memory corruption is basically where you've got, say, on an object manager, you've got multiple threads running, object manager process, multiple threads running, and it's where one of the threads can basically violate the memory that's pertinent to another thread. So from a troubleshooting perspective, it's very, very difficult to get a handle on the root cause of this, because even though we know the thread has failed, we don't know which other thread on that process has interfered with the memory of the thread that's failed. So it can just kind of randomly spray problems across the heap, and therefore we don't know which thread has been the root cause. Okay, and the third broad categorization is insufficient resources. So basically, resources could be anything from memory to file handles, but basically it's where the resources are just simply run out. So we could be talking about a memory leak, or it could be the case simply that a given user is running a specific function that requires loading a large amount of data. For example, I'm working on a crash at the moment, or I was doing earlier this week, where a customer was running a Siebel forecasting routine, and the sheer amount of data that was being processed there was causing the call stack as the given user session to burst out the top of the stack. So that was a stack resource issue based around the amount of memory that was being needed to be used. Or it could be down to poor system or Siebel configuration, so perhaps there's too many processes physically running on a server. Okay. Right, so this is the first of the kind of immediately useful to your role slides, or I hope so anyway. I've done a blow-up of it on the next slide. So what I wanted to do here is to specifically establish what a end user will see when a crash occurs. So quite often we see service requests being raised where the administrator might say, Siebel users are reporting session warning errors. What's going on here? And certainly at the forefront of my mind when I see an SR like this is the fact that it's typically down to a crash. Not always, but typically session warning errors are when the object manager has just aborted and the process is no longer there. So hence all of the user sessions attached to that specific process have been disappeared basically because the process is gone. Sometimes it can be down to a network problem or something else, but so let's say 19 times out of 20 this error would be based around an object manager crash. So yeah, as I mentioned there, every user session on that specific object manager process will receive that dialogue irrespective of whether that given user was the user that caused the crash. So when the user clicks the OK button, the browser session will either go blank, completely white, or the Internet Explorer will itself close. So the last uncommitted work being performed by the user will be lost for each session. As of Siebel, I think it was one of the early Siebel version 7s, there's a parameter on the object manager which automatically restarts the process. So pretty much if the user closes their IE browser and then tries to log in again, chances are that they will be able to get attached to another object manager process, either the one that's immediately been respawned or one of the other multi-threaded server processes. Okay, so that's from the user perspective, and from the Siebel administrator's perspective, we sometimes see service requests raised where the customer will say, we have these crash.txt files or these FDR files, what are these? We don't know what they are. So basically these are generated when the crash occurs. I'm going to go into detail in a little while, specifically around the contents of these files. But it's just to make you aware of fundamentally these are the diagnostics that get generated when the crash occurs. And as a Siebel admin, you may see these. Another key indicator as well for when a crash happens, there's a process exit event entry in the Siebel Enterprise log file. So this will typically include an exception code or another sort of error. So that will tell you the process has gone down. Quite often as well, that will shortly be followed just a few seconds later by a respawning of the given component. And there also can be an entry at the end of the individual task log. So in this case, I've chosen to use an example from an object manager session log file. This is not 100% reliable, but quite often you will see the call stack and registers and other pertinent information at the end of the object manager major session log that caused the crash. And the other location as well, where you may see crashes showing up, or the presence of crashes, is in the Windows application event log. So the source is always going to say Siebel application, and pretty much this is a replication of the information you would see in the crash.txt file. So we would see the call stack and registers information there in the file, and it's kind of flagged up with this red cross or red circle, white cross as an error. And the other thing, just slipped in at the very end of the slide there, is obviously if you've got something like MS debug diag running, or perhaps the older user dump Microsoft tool running, then you may actually see crash dumps generated, so .bmp files, wherever you specify for those to go. Okay, so from both the Siebel and the operating system perspective, we'll look now in some more detail at the specific elements of diagnostics that you're going to care about, basically from a crash troubleshooting perspective. Okay, so it's really, really important to establish the conditions that were happening before the crash occurred. So when Siebel is running in a steady state, the enterprise log tracks component level events, and the individual server component and task logs, these capture information about the specifics of the given components. So depending on how high or low your event logging is, there'll be different levels of diagnostics, but even in some cases, even a fairly low event log level can show you an error message, perhaps immediately preceding the crash, that's useful in troubleshooting the crash itself. So it's basically giving some precursor information to a possible root cause that then led on to the crash. And of course the operating system as well is recording information, like I mentioned in the Windows event logs. Okay, so when the actual crash occurs, what we see is an entry in the enterprise log, as the prior example showed, and also the server component and task logs. The crash.txt file should be saved, and also we've got this concept that was introduced about, trying to remember which version, I think it was Siebel version 7.0 initially, and then it was a much improved version came out in Siebel 7.7 and 7.8 of the SDR files, the flight data recorder files. So these hold a running buffer of the information. And again, operating system, we've got the dump file, or the Windows event logs. Okay, so the enterprise log that I would expect Siebel admins and support people to be quite familiar with anyway is has the naming convention of the Siebel enterprise name, and then Siebel server name .log. It's located in the Siebel server log directory, and the important information to take from this log file is that there basically could potentially be multiple erroring components, either exiting or throwing errors. So this could be an indication of some sort of connectivity problem, or perhaps a resource problem that's showing up in the enterprise log before a crash. It also shows the context of whereabouts a crash might be happening. So we can see entries in the enterprise log that indicate both time-wise, and also there's an entry to say when the Siebel server started. So you may be able to establish that the crash is starting either during the startup of the Siebel server, or as the third point mentions there, that the crash might actually be occurring when the server is shut down. And also you might see a block of crashes, so perhaps multiple components crashing all at the same time or within short order, which basically is a good indicator that there could be a quite a generic cause. So we wouldn't be looking then specifically at the given problem with a component. We'd be looking more broadly at problems with perhaps the machine or the network. Okay, so here's some steps that's very, very useful. We actually document these in a Oracle support document on which is basically the crashes on Windows document that you may have seen. And this is the fact that in the crash.txt file there's the process ID and the thread ID of the crash process and thread. So slightly antiquated, but these values appear as hexadecimal values in the head of the crash.txt file. But it's possible, obviously, just using the calculator on the scientific mode just to convert these to decimal. Because the value and importance of doing this is the fact that we also get the process ID and the thread ID in the first line of every Siebel task log, basically. So we have the task ID, the process ID, and the thread ID all in order on the first line of the log file. So in this example here, we've converted the process ID and the thread ID to decimal values. And then we can use either those values or perhaps the term call stack that also may appear in a component task log to search. I really wish, actually, on this slide that I'd have used the process ID and the thread ID in the box there on the left-hand side. So where it says a word or phrase in the file as call stack, equally as much you could search in there with the text 3952 space 3140, because this would also find the same log. Okay, and the server component log is absolutely key as well to understanding, especially for things like object manager crashes and workflow process manager crashes. Specifically, what steps were happening in the immediate run-up to the crash. So if you've got the event logging quite high, then this is very helpful. But obviously, appreciate that in production systems, it's difficult to have this running on an ongoing basis because it can have an effect on performance. But basically, if you have got it, or if we get to the stage whereby we're starting to go through some iterations of repro cases for a crash, then the clues that we're looking for here is the preceding steps. So we want to try and broadly understand what the user was doing in the run-up to the crash. So the task logs, the component task logs, can be orchestrated to include a vast amount of information. So we can see specifically the different views, screens, views, applets, and methods that the user navigated to. And you can also see in the event logging things like the name of workflow processes and perhaps the workflow process steps, and also specific business services, scripting and SQL, basically all of the things that are going to help to build up a picture of what the user was doing so that you can work towards a repro the repro case together to understand the cause of the crash. Okay, so I mentioned there that obviously it's generally not possible to have a high level of event logging on the object manager, but there's two very, very common and fairly unintrusive event types that can be increased with very, very little performance impact. I've never ever come across a case where customers had a problem setting these in a production environment. There's always been some trepidation, but then that's soon been quashed. And these two are, the first one's quite a mouthful, the object manager session operation and set error message log. The alias is object manager session log. The key thing about this is towards the head of the log file, it gives the user ID, so that the user's login details in the log. And the other thing is event context, and this is the thing that gives the screens views, applets, and method calls. And I've just put a little screenshot in there just showing how you can increase those from Server Manager command line. And of course, we've got a document how can tracing be increased for the Siebel Object Manager, and this gives details of more events as well that you can increase. So here's those two events in practice. So this is the entry that we would see in the user session log with this object manager session log event type increased to value 3 or 4. So specifically I highlighted the text there, new user equals, so this is where it switches the context from the anonymous user that's used to render the login page, and then it switches to the user that's logged in. So in this case the user ID was CUMBN01, and the advantage for this is for some crashes it can always add an extra dimension if you can get on the phone or even walk over to see the user and ask them, perhaps get some additional information about what they were doing when the crash happened. It tends generally to be useful when the crash has happened in a short succession. So several days later, there's little value in going to see the user, but if we can catch this quite early, then it can be quite valuable. And the event context, just a couple of examples here. So we see the user navigated to the view, got home page view, and then the event context for the applet is the fact that they navigated to the account form applet and performed a new query, which is the method name in brackets there. Okay, and the crash.txt file, this is in the Siebel server bin directory. It's incremented with each crash, so it's crash underscore and then the number 1 going on to 2 and so on. It contains the call stack, the process name, timestamp of the crash, and other information, but mostly it's the call stack and the process name, timestamp that we're interested in. The call stack is without any doubt at all the most critical diagnostic element for identifying crashes. This is what we call the signature element for a crash. We try basically to publish any crash-related issues on Oracle support tend to include the call stack. If they don't, if you come across a document that doesn't, then please feel free to drop an update in the document. There's a comment facility where you can say, is there any chance you can add the call stack for this? And Oracle support, last bullet point there, should be basically the first point of call for diagnosing any crashes. So you can search with the the first few lines of the call stack on Oracle Support. So we've got an example here. So I just used this from a crash from a couple of years ago. So this is the call stack that we'd see in the crash.txt file or at the end of the session log, and then using the header line, the top frame from that call stack, we searched initially using the full call, including what's called the offset at the end of the function there, that hexadecimal reference. But if we didn't have any hits on that, then we could perhaps remove the offset and just search on the class name and the function name. And next slide shows an example of a couple of hits that you'll find if you do this right now. Please don't know. But if you do it after the presentation, you'll find for that particular crash. So if there were no hits, though, then you'd want to search with the more general example there. Okay, and here we've got the flight data recorder file, the FDR file. This is basically a 5 megabyte rolling buffer of the contents of the actions being performed by all of the user sessions, say if it's an object manager process. The beauty of this is it's always enabled, unlike the component events, and it's dumped at the point the crash occurs. So this is an automated process, and this is massively useful from our perspective in support, because if we don't have decent amounts of event logging on the component, then this is a great way to be able to check for the most recent events. So it's dumped as a binary file, but then there's a utility in the Siebel bin directory called the SAM analyzer, which is used for two purposes. But the purpose here is to convert the FDR file to a human readable format, so the CSV file, comma separated file, basically, that we can then read and analyze. So CSV file can typically be opened with a spreadsheet, so maybe Excel or the Oracle OpenOffice product, and then you can search, sort the file by thread ID and then by what's called the FDR ID. So there's about 7 or 8 columns in the thing. So the FDR file, you see, contains multiple threads, not just the thread that crashed. It just literally is a rolling buffer of all of the actions, regardless of users. And then it's possible in Excel to add a filter using the first row, and then you can search for the text, say crashing thread or crash, and then you'll see an entry for the specific crash thread that has an entry in there to indicate crashing thread. And then what I tend to do, I don't know if any of my other colleagues do this, but what I do tend to do a color coding of the rows in Excel, and the next slide sort of shows this. So this is a very similar way to the event logging. It gives us a list of the actions being performed by the user. So here's my beautiful Excel example that I've color coded, so you see. I hope that the font's readable. Sorry, I had to kind of squeeze this onto the slide. But you can see at the very end of the last entry there says crashing thread. So this is read top down. We can see I've highlighted in there all the entries for scripting. I've specified in green, so we can see there that there was an allocation for the contact business component, and then further down we see a custom component called ABC contact history, and we can see other events in there like a set search spec and so on. But it depends. For some crashes the information can be very useful, for others not, but generally it's a real great kind of saviour for the initial understanding of the steps that the user's taken. Okay, hope that was clear. Right, next part is generating dumps. So we've got a couple of documents on the Oracle support site that we'll be updating in the relatively short future that use a couple of the older tools. But now, for the last few months, I've been, my colleagues as well, have been advising to use a newer tool called Microsoft Debug Diag. You can search for this on Google using Debug Diag download. Very, very easy to install, and it's used for troubleshooting things, performance issues, memory leaks, and context that we're interested in here is process crashes, basically, specifically Siebel process crashes. So typically we wanting to install this on the Siebel server host machine. Okay, and I've got a few shots here of the wizard that's used for adding a rule to monitor for certain crashes. So this is launched when Debug Diag first launched, and when there's no rule in existence. So what we want to do, we want to take the default option. We want for it to analyze for a crash. We want it to be for a specific process or process name. The next dialog then gives us a list of the processes running on the machine. So you can, at this point, either select a process, in this case the CMTSH MW, which is the object manager process, or any multi-threaded Siebel process. So we can either select that. Important thing is here to leave this process instance as unchecked, because we want it to be basically the rule to catch any CMTSH MW process crashes. Next screen we leave as the defaults because we only want the second chance exceptions. Next screen, again, typically you'd leave this as the default. The only exception I can think of, perhaps for a production environment, is where you may want it to redirect the generation of the dump files to a separate partition instead of the actual partition where Siebel's running. And then that's it for the rule. Very, very easy. We just want to activate it. So click Finish. And then there's the new rule, which is in the main Debug Diag screen. So it's currently showing there as active, and the user dump count is 0 because there's no dumps at the moment. And you can actually exit from the tool at this point, basically because the Debug Diag runs as a service called Debug Service, which is the actual functionality that monitors for the crash. Okay, so we then jump to the case here where a crash has happened. So the top part of the screenshot there is showing us Siebel Enterprise log, so we can see there that process 3436 has crashed, and the Debug Diag tool has picked up on this and generated the dump exactly as we've configured it to do. Okay, whistle stop tour there of Debug Diag. It's very, very straightforward though, far better than the previous tools from Microsoft for dumping. Now moving on to RDA tool. Basically, the remote diagnostic agent. This command line tool that's used by many different parts of Oracle, as in different products within Oracle, Siebel being one of them. And it basically captures a whole bunch of diagnostic information for Siebel or for the particular product type that you pointed to. Oracle specific tool. There's another concept in RDA called the RDA tool. This generally captures more detailed information, and Taylor, who's on the Q&A session, Taylor Shock, he was basically the driving force behind getting this Siebel tool, Siebel crash tool in place. It captures a lot more information, including gathering up potentially the dump file. Okay, latest version is 4.26, but the Siebel element was introduced from 4.25 in, I think it was around October time last year. And the purpose of it really is to save you a job, and that is it can gather a whole set of information about a given crash if we tell it the process ID of the crash and point it in the right direction. So scenario is we've got this dump file that was generated, and we want to be able to point RDA towards that to perform the gathering process. So this is the screenshot of the command line of running the tool there. So specific point to note, it's very, very critical, is the fact that all of the options and parameters for RDA are case sensitive. And the way to run the Siebel crash tool specifically is to specify the standard RDA command, and then the option is -v for both, and a T for tool or test module, and we're telling it we want it to run the Siebel tool, basically. And I've highlighted the options there, so we're specifying the directory where the Siebel server is located, the name of the enterprise, name of the Siebel server, and in this case we actually want it to run what's called the advanced mode, and the advanced mode is to gather a dump file as well, and we specify both the path and the name of the dump in the screenshot there, and also the very last entry there is the process ID of the crash process. Okay, and this is the output that's generated. So this is in the RDA output directory, and this is generated directly as a result of running the RDA tool. So we've got the crash.txt file again with a prefix of RDA, the crash summary page, the HTML page that we can launch, which you'll see on the next slide, and any relevant component logs that it pulls out pertinent to that process. It also very kindly converts the FDR file, so no need to run the SAM analyzer explicitly, and it also scratches the FDR file out of the dump if it's not present. And in this instance, we ran it in the advanced mode, so it also pulls in the dump file as well. Okay, so this, if you open up the output, the HTML output, this is the page that you see, where we see essentially hyperlinks to the various elements of the crash. So essentially the RDA is saving us the job of manually going to look for things. It's gathering them all up for us. Okay, and then you can actually perform the gathering process by running just the standard Siebel profile for RDA, and then this will bundle up standard Siebel RDA profile, which gathers a much broader diagnostic snapshot of the Siebel server and the Siebel enterprise, as well as gathering the Siebel crash information as well. Okay, and this is the resulting zip file after you've run that command, and ideally you should attach this to the the service request that you've got open with us, because the portal has a special way of flagging to the owning support engineer, i.e. to myself and my colleagues, that there's some RDA content associated with the SR. But if it's too big and you're having problems maybe attaching that through the browser, then you can always provide it via the Oracle FTP site. Okay, so as I mentioned, the current version of RDA as of this month is 4.26, and I've put a couple of links on there, a couple of documents that discuss the overall usage of RDA, and also RDA specific to running it against the Siebel product. Okay, right, sorry, it's quite a hefty pace that we're going through the slides. I've just got my eye on the time. Right, now, basically, intent of these last few slides is to get an understanding of how ideally we would like you to work with us in Siebel support. First thing is the crashes. If you can give us a specific date when the crashes started, that would be very useful. How many users are affected by each crash? This as well enables us to get an understanding of the criticality of the crash. Frequency, some crashes might happen once a week or even once a month. Others might happen 10 times a day or more. So it's important to establish that. And any other elements that might correlate with the same time period. So perhaps if you're having some performance problems or some other errors, then just let us know. Okay. So any events pertinent to prior to the crash occurring. So instead of saying, oh, we've started having a crash, if you can let us know if you've perhaps released a new Siebel SRS or released some new workflows, perhaps applied a patch, that might be a Siebel patch, operating system, database, or a third-party tool, or perhaps some SSO implementation, just literally any critical information that might have affected the environment before the inception of the crashes, because all of this helps to build up a picture of a possible cause. And of course, the steps that you've taken as well, as this slide demonstrates, that you might have done. So any of your hard work and due diligence to establish the root cause of the crash. So perhaps you've searched on Oracle support and may have even dismissed some documents. That would be useful to know. If you've established if it happens at a certain time of day or time of the week, any views or applets, because you've already looked at maybe the FDR file or the event logs in the object manager session log. If it's consistent or inconsistent when in its reproduction, so is it completely random, or have the users reported that there's a certain set of steps to take when the system goes down or the system crashes, and any work that indeed you've done with the users to help identify a crash. And the panacea is basically it's a very pleasant scenario to see an SR raised where customers already done all of the due diligence and can say, yes, we can reproduce this crash using perhaps the vanilla SRF, and these are the steps that we take. That's just obviously the ideal scenario, if possible. Okay. And of course, as much of the content of this webcast has been around, is the diagnostic information to support the case. So ideally now what we'd like is the RDA crash tool having been run, but if you can't provide that, then the specific diagnostic elements to support a crash, so the crash.txt file, the SDR file, and the conversion to the CSV file, because it's best if you convert it in the context of your environment. Siebel Enterprise log, component task logs, and the dump file. If you're in doubt at all about the logs, specifically what logs to provide, then you can zip the whole log directory and provide that. But if you can do the due diligence to seek out the specific task log, that's the best thing to do. Okay, and here's a kind of a scale. I should have some sort of fancy graphical scale or something here, but essentially there's a scale for the different types of crash that can happen. I want to be very clear about articulating this, because especially in the very bad crash scenarios where the emotions can run high, sometimes I completely understand frustrating for customers, where we ask for multiple iterations of log files and dumps and so on. Sometimes it's difficult for the Siebel administrator or the underlying business to understand perhaps why we're asking for multiple cases, and that's down to the fact that crashes, some of them can be very, very straightforward. You can match the call stack of the crash immediately to a known bug or known issue, and you can self-serve on this and may never raise an SR, may never have a necessity to come to us, through to cases where we have one or two or three iterations of looking at different sets of diagnostics, logs, dumps and so on, to get to the root cause. And then at the very difficult end of the scale, these tend to be the ones that are the greatest pain issues from both sides, and that's the fact that it requires many iterations of looking at dumps, and these are the ones where customers tend to ask, okay, why do we need to provide so many logs? And it's basically because it's very difficult to understand the root cause. These are typically things like the memory corruption crashes that I mentioned at the beginning there, and they're very difficult to establish. Okay, lastly, this is the final slide of the deck. So I just wanted to say that some crashes are difficult or in fact nearly impossible to resolve, and indeed they might just quite literally stop occurring by themselves with no obvious reason. And the reason behind this, though, obviously, as we know, it's not that there's no reason it's stopped occurring. There's always a root cause. There's always a reason. It might simply be the fact that the business is no longer using that part of the application. So this is the reason the crash has stopped occurring, because that piece of functionality is no longer in use. It might be a very, very rarefied sequence of events that a given user is taking that's causing the crash, or the configuration or scripting change that's inadvertently being implemented might resolve a crash, so just some incidental change, or indeed a operating system, database, third party or Siebel product fix has introduced that has again incidentally resolved the crash. So conscious I've been talking for around 55 minutes, I'll very, very quickly now move on to the lab elements of this. Let me just share my desktop here and jump onto my lab server. So I think what I will do is, because I'm running short on time here, I'll actually show you setting up. I think one of the critical things to show is to set up the the rule in debug diag to capture a dump file. So I've got the rule in place, excuse me, got the rule in place here already. This is for the CPROC MW process, which is a process for the server table cleanup component. So it's one I created earlier on, so let me just actually delete that rule, and I'll go through the steps to recreate it. So here's the step. So we want to create a crash type rule for a specific process. Siebel server currently isn't running, so I'm going to specify here manually the name of the process, CPROC MW.exe, and because it isn't running, debug diag actually wants to confirm that it's a 32-bit process. So it's shortcutted to the Sieb server bin directory, and I can then select the CPROC MW executable there. We only want the second chance exceptions, so we click next. This is the name of the rule. This is the location that we want the dump files to be presented to, and we want to activate the rule now. So I'll click finish there. So we've got the rule in place, and what I'll do now is I'll go to start the Siebel server. So I'm working on an issue at the moment for a customer, and seeing a crash with the server table cleanup component, and it's quite a bad issue. Basically, the component can't be started. Our engineering group has got a fix coming out for this particular issue related to the DB2 client, actually, in the coming weeks. So as the server starts, the server tables cleanup component starts. So I'll just go to the log directory here of our Sieb server log. It's cleared out the old logs, and we can see it here starting to establish the various components. So I'll just hit F5 to refresh, and perhaps open up the enterprise log. What we can see here, it's starting up the components. Hopefully what we should get in a second, there we go. At the top here we see the server table cleanup log file. So I'll just refresh on this again. And if I then revert to the bin directory, we should be able to see in a second a new crash.txt file being generated for this crash. Just close out this log. Okay, so here we can see the server table cleanup logs. Just go to the bin directory again. Okay, no crash.txt file yet. Let's have a look at the debug diag. Okay, here we go. So here we've got the debug diag utility is now recording three dumps for this. So we can go to go back to the rule, and then we can say to analyze the data. Okay, and I think because we're at the top of the hour now, I think what I'll do, sorry, my apologies, I'd hope to show more on the labs, but it's literally all the lab element was to do was to act as a additional element to the screenshots. Pretty much it was what we've covered in the screenshots. So I think I'll refer back to the slide deck, and I think we'd better move on to the Q&A Q&A session. So let me go back here. Okay, so Pam, I think we can go to the Q&A session now, if that's okay.
Okay, I want you to go to the Q&A slide then.
Okay.
Okay, thank you, Paul. We hope everyone found the presentation valuable today. We'll open our Q&A in just a moment, so please use the chat feature or the phone lines at this time to let us know you have a question. Kimberly, could I ask you to give instructions once again for those on the phone lines?
Sure. As a reminder, if you would like to ask an audio question, please press star, then the number 1 on your telephone keypad. We'll pause for just a moment to compile the Q&A roster.
And while we're pausing, I just want to remind you that the download and streaming link to this presentation will be posted on My Oracle Support under My Oracle Support Training Central. And then you would click on Recorded Training. And this will be done in approximately 48 hours. If you're more comfortable with using doc numbers, you can go to doc number 740964.1. And that's a list of archived advisor webcasts. So let's see here and get to our first question. Can you give all the causes for scripting based on crisis and how to fix them?
Paul, I wish I could. It's almost impossible question to answer that one, though. I don't know. There's no real valid answer to that one. There's so many different possible root causes, and of course, if we knew the answer or could possibly predict the possibilities for crash for every type of scripting crash, then there would be exception handling within the scripting engine to handle this. So it's part of the scripting engine actually provides flexibility to you as customers to customize Siebel to your specific business needs. So along with that, unfortunately, comes the responsibility of treating the script that you write just as you would if you were a software engineer writing your own C program, for example. So the short answer is no, sorry.
Okay. Thanks for the presentation. Why would you get a OKB crash.tex file without an FDR?
Maybe let Andreas answer that one.
Don't forget to unmute your phone, Andreas. Kimberly, is his line still connected?
Yes, he's still connected.
Okay, no problem. Maybe I'll answer that one. So it's a 0 KB crash file, is that right? And no FDR file?
Right.
Yeah. So typically the 0 KB crash.txt file and no FDR file relates to where the process has run out of memory. So there's not definitely, but there's a good chance it could be, if it's consistently happening, then it could be down to a memory leak on the given process. So essentially the process is become memory sort of bound, and it doesn't have the capability to properly run through the Siebel's crash handling routine, which does those two things. So it creates the crash.txt file, and it also creates the FDR file. So the crash.txt file can be 0 bytes, so it's been capable of writing a file but not the contents, and the FDR buffer just can't get obtained. So looking at a potential either high memory usage or memory leak scenario there typically.
Okay. Do you need to download the RDA tool, or does it come as part of the install package?
One of the RDA, in fact the first of the 2 RDA documents on the slide there, you download it via this, and yeah, you basically download it, install it on the machine, and the setup's fairly straightforward. In fact, as Taylor's the RDA specialist, I'll let him add to that if he wants to. Taylor?
Yeah, it is a fairly straightforward process. Customers I've worked with in the past, I basically ask them to do, pointed them to the document, and the next response I hear back from them is they've actually uploaded the file, the output file. Also, RDA is not just for Siebel usage here. It's used very, very much so with the Oracle database folks as well, and some other Oracle products. One of the good things about RDA, too, is it's sort of an install once, run many kind of tool as well. So if you're working on crash issues or even different issues, you can use it not only for crashes but for other Siebel issues as well to gather information. So it's a fairly easy tool to use, and it's a fairly complete tool to use. But of course, we'd always use input, or if there's issues with it, we'd love to be made aware of those.
Okay. Enabling debug diag tool on Siebel server will have any performance impact?
Not to my knowledge, actually. It's just like any of the other Microsoft tools, like the old AD Plus and User Dump. Essentially, it's a fairly non-invasive tool until it needs to do what it needs to do, which is to generate the dump. So the process of generating a dump is quite intensive, but that performance intensive. But at that point, that's the whole crux of why we want the tool running. The MS Debug Diag simply runs as a service, and I've asked several customers now to run it, and they haven't reported any problems. And it's obviously a Microsoft tool that's used for any process crashes at all across any Windows client or server system. So they've obviously built this thing with non-invasive behavior in mind.
Okay. Where can you download the RDA tool?
Taylor?
I'm sorry, I was on mute. Where can you download it? I'm sorry.
Yes, that's the question. Where can you download the RDA tool?
It's the reference in the document. In the first document, I believe it actually gives you the link to the download for RDA, and the RDA download is downloaded by platform, by OS. It's in the first document link there about the introduction to RDA. It also is in the other document, how to use RDA with Siebel installation. It's in that document as well. There's a link within there where to get the tool, and it's downloaded. And it also tells you in the document exactly where to put the RDA tool when you download it and how to run it.
Okay. If you already see an object manager task is in handling requests, just a second, state for a long time, and you know it might be at some time crash, the OM, is there a way to kill that specific task without killing the whole process on Windows?
You can kill tasks, but it may simply have become completely unresponsive. So it's a difficult one to answer that generically. It's more, I would advise that customer to raise an SR for that issue.
Okay. Are RDA and debug dialog utilities available in Siebel 7.8 also?
Debug diag is a Microsoft utility, and that's not necessarily tied to a specific Siebel version. So I believe that will work. And the RDA is, yes, it's valid for use, and it's been tested for use in everything from Siebel 7.7 on up.
We still have a lot of questions, so I want to try and get through those. through these, but we're running out of time here. Can we get the symbol strings to analyze the dump files?
Unfortunately not. The only cases where symbol strings have been provided is where there's been an occasional case, and I haven't known this for a long time now, where there's been an engineering representative needed to go on site, or an Oracle ACS person on site to deal with that. But unfortunately, no, the symbol strings can't be provided.
Okay, a lot of my crash files are empty and no FDR file is generated. How can I debug this without the FDR file?
Same scenario as the other customer. Chances are that's indicative of out of memory exhaustion issue, basically. So in that case, I would encourage the customer to get the MS debug diag set up and to start to generate some dump files for that particular crash, because chances are we would see a consistent process size being dumped.
Okay. Are the debug tool and RDF tool new features in Siebel.8 only, or are these available in 7.8? I think you already answered that question.
Yeah, Taylor got that one.
Okay. We see Object Manager tasks not getting completed even after timeout. We had set at SWEA apps. This results in increase of tasks granularly and reaches mass tasks of Object Manager sometimes. We do not see any crashes. Can this be attributed to memory leak?
Or a bit specific for the call, I'd encourage the customer to raise an SR for that particular issue. Sorry, without looking at the details, it's really difficult to answer.
Okay, and I will be sending you these questions so you can possibly get back to these customers on a one-off. Okay, at this point, I'm going to have to close out the advisor webcast. I will be sending the remainder of questions to Paul and ask him to get back to you on a one-off basis on the remainder of the questions. I apologize for that, but we do have a allotted time for these webcasts. So with that, I want to thank Paul and thank everyone for joining today's Oracle Advisor webcast. We hope you found it valuable, and we look forward to you joining us again. Thank you very much.
Thank you. That does conclude today's conference call. You may now disconnect.